Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rifqi and this is my friend Muhammad AZIM. So today we will be presenting our PLC mini project which is titled Sardine Canning Process Using Conveyors in Factories. So these are the table of contents. There are 4 chapters in this presentation. Chapter 1 Introduction, Chapter 2 System Development, Chapter 3 Results and Discussions, Chapter 4 Conclusion and Recommendation. So firstly, we will talk about the project overview. The sardine canning business is leading the way in implementing automation to improve efficiency, uniformity and quality control to advance industrial process. So this project will integrate the cutting-edge technology such as PLC and CS programmer to handle the complexities of the sardine canning process. We had an automated system triggered by a start button which sets in motion a series of conveyors, sensors and a robotic hand to coordinate the smooth transition of sardines from can filling to packing. We reduced the amount of manual intervention, increasing manufacturing throughput and guarantee a high quality standardized final product as the objectives. This project will represent a revolutionary method of canning sardines by integrating advanced automation concepts with conventional procedures. So this is the design process layout diagram. The canned sardine manufacturing process, they follow a systematic sequence to ensure the production of top quality products. It begins with the inspection of fresh sardines, and the sardines will undergo cleaning, gutting, and pre-cooking to prepare them for the next stages. So the process includes detecting empty cans or defects with a diversion mechanism for identify issues. Weighing and mixing will follow, incorporating precise measurements and ingredient combinations. And the cans will be labeled with essential information and quality control measures are maintained throughout the process. After packaging and storage, the finished cans are distributed to retailers or wholesalers for consumer availability. So we focus on the conveyor system for simulation purposes. The project specifically emphasized the stages that involve the movement of cans from one place to another. This selective simulation centers around the efficiency and control of the conveyor system. By concentrating on the conveyors, the project aims to showcase the automation and precision involved in the transportation of cans within the designated areas, highlighting the impact of the conveyor system on overall production efficiency. So this allows for a detailed exploration and real-time monitoring. So it will provide valuable insights into the integration of automation technology in a specific subset of the comprehensive canning process. So these are the objectives of our mini project. Firstly, we are to design an efficient conveyor system selected for simulation, to develop and implement PLC program to control the operation of the conveyors. We also aim to integrate the conveyor system into the simulated sardine canning process, ensuring smooth transitions between different conveyor control stages. And lastly, to create a simulated environment that accurately represents the selected stages of the process. So it provides a realistic context for the conveyor system simulation. So this is the problem statement for our project. The traditional sardine canning process, they involve manual labors and they lack the precision required for large-scale production. There are inconsistencies in the production line. So they increase the likelihood of errors and they can impact product quality. So this project will address these challenges by introducing the automation and advanced control systems to streamline the manufacturing process.
Okay, so this is chapter 2, which is system development. So this is the input and output that we use in our PLC ladder diagram. So as you can see in the left box is our input, which is start button, stop button, sensor 1, sensor 2, and sensor 3. And the right side of them is their address, which is as you can see. So then the right is the output, which is conveyor 1, conveyor 2, and conveyor 3, and also new box. This new box is a sensor that detect 10 canned sardine and will add a new box. So this is our PLC ladder diagram. It starts with stop and also has a counter and also has timer, as you can see in the figure. See from up above, we start from start and we end with timer 2. We use load, or and not, and also as you can see in the slide.
So for the results and discussion, this is our project layout that we designed using CX Designer.
This is going to start button.
So this is the ladder diagram when start button is pushed. So as you can see in figure 3.4, when the sensor 1 detected canned sardines, it activated, and conveyor motor 2, when the start button is pushed, the conveyor motor 1 is turned on and it will start moving toward sensor 2 through sensor 1. And when sensor 1 is on, the conveyor motor 2 is turned on and it will start moving toward conveyor 3. When sensor 2 is on, it will turn on conveyor 3 and start moving the canned sardine into conveyor 3, and on conveyor 3, the sensor 3 will count 10 sealed canned sardines and filled with 10 sardines into somewhere else and put a new box which is empty to be filled with the next sardines. So this is when the stop button is pushed. When stop button is pushed, the all the components will turn off. So this means the program repeats the cycle as long as the stop button is not pushed.
Okay, so this is chapter 4, which is conclusion and recommendation. So in conclusion, this project is successfully negotiation and complexity of industrial automation. So we focus on sardine canning process, conveyor system optimization. We accomplish a significant advancement in order to improve the effectiveness, and we want to manage this vital component by painstakingly planning and modeling a conveyor system specific to increase the manufacturing paces. So in order to do this, we demonstrate the transformative potential of automation technology. by creating a project that took a multi-factored approach that include developing and implementing programmable logic controller (PLC) and also integrate real-time monitoring and also creating an intuitive user interface. So the success of this project depend on how well we control logic coordinates of the conveyor system. By reducing downtime and increased output, we can also include a real-time monitoring promotes proactive system by increased operational transparency and also can provide operator with instantaneous insight. By embracing this error handling technique, we can increase the efficiency through documentation and also we can research and establish the groundwork for further effort in conveyor system optimization. The extensive application in industrial automation will create a project real-world application by demonstrating it out. This show how it may transform conveyor system and add into growing body of knowledge and how automation affect industrial process. So as you know, not our project is not perfect enough. So we have some recommendation that we can use to increase our project efficiency. So firstly, we can increase the system of the cadet sending process by learning more about the PLC features. And also we can combine motion and control modules and by investigating high-level PLC specific programming language. The accuracy of the conveyor system and flexibility may be improved by extension and bring it more in line with practical industrial uses. Through the use of PLC functionalities, our model can be able to demonstrate not only effective conveyor motion, but also a complex control strategy that can raise the total automation effectiveness in the chosen canning process. Furthermore, our project is centered around PLC programmable logic controllers. It is imperative to consult with industry professionals. When we consult with the professional, we can make an effort to work together with them in food processing sector because they have experience in that sector. We through this partnership, we can get an insight into solving the difficulty faced by the SARDINE canning business. We can also reduce the compliance issues and create a creative PLC solution. And also we can initialize the conversation with professionals in the field. This can guarantee that the project is in line with the realistic need, but also it can also develop a hands-on comprehension of PLC best practice. We can enhance the project relevance and application in the context by this partnership, and also we can automation SARDINE canning process. So this our present ends here. Thank you for listening and subscribe.